All right, everybody, welcome tonight to the YouTube Model Builders Barry and Mike's MRR Tech Show. Tonight, our guests will be me and Andy Crawford. Mike can't make it apparently because he has some management team meetings with his new job, and Chris may be in a little bit later. So tonight we will be discussing model railroad signal hardware, all the electronics you need for your layout to make your signals look and act the way you want them to. Okay, where's my mouse at? All right. So, everybody, just remember tonight's show is sponsored by YouTube Model Builders. It's your online resource for model railroad information. We have our free online e-magazine, the live chat presentation hangouts that you're part of tonight, and we also have our once a month live show, YouTube Model Builders Live. So make sure you check out www.youtubemodelbuilders.com, and you can go over to the eMag, pull down and subscribe so you get notified whenever the eMag gets released. And also, you will be able to get emails as we send them out for periodic special events, etc. So we're using that avenue to send out notifications as necessary. And our YouTube Model Railroaders Google Plus channel is now over 1,000 members. So I'd like to congratulate everybody for joining on board. So let's hope this community keeps going and growing. Okay, reset everything here. All right, so like I said, tonight's discussion is on what kind of hardware do you need to implement signaling on your model railroad layout. What I've decided to do is focus on a couple of vendors, showcase what some of their products are, discuss a little bit about how everything interconnects, and discuss what systems you can use it with, etc. So the first thing we'll talk about will be Digitrax, and then we'll talk about RR circuits. And there's another one that I have to go pull up the web page for later, but if we get a chance, I'll talk about a thing from the UK called the Signalist, which is a simple signal system. But the advantages of the other stuff we'll be talking about is they're all DCC connected with JMRI for control and everything. So that's usually our preferred method of operation, but you can certainly do your own standalone signal systems that do not require a computer. Our circuits has some stuff that works that way, and also we have like Signalist is another one, and there's other vendors out there as well. I mean, we can't obviously cover everybody, but tonight we will probably cover the two of the bigger ones on the planet as far as signaling hardware. So let's get in and say hi to our buddy Andy here. So how you doing tonight, Andy?
I'm getting along. I made it through Monday, so I'll take that.
I'm with you on that one, buddy. I really am.
That's IT world for you. If you were looking for an easy job, you should have made a lawyer or something. So
Yeah, that's true, my friend. That is true. All right, so let's pop up. We'll go here first. We will go to the Digitrax environment. Now, mind you, everybody said, why don't you discuss NCE? I can hear it now. I can hear the echoes in the background.
yep.
All of this can be used with NCE. The biggest issue with NCE is they really don't have a signaling product. There's been talk of one. I don't know where it's at, but they had developed some hardware that they hadn't marketed yet. So it may come eventually.
And they're compatible with a whole lot of the third-party stuff.
Yes.
But you get into this combination of things that is a lot for people. If you want a whole solution bought from one vendor, Digitrax is probably the only company that you can just call them and say, "This is everything I want," and they can sell it all to you in a Digitrax box.
Yep.
But anybody using NCE, like you were saying, anybody using NCE can still use their signaling stuff.
Yes, because with JMRI, you do have the advantage of that you can have multiple connections into different control buses. So for the NCE users in the crowd, you would go to RR circuits and buy yourself a loco buffer USB, and that ties into JMRI, and you use like the USB interface for your NCE system, and the loco buffer plugs into a LocoNet system, so then you can plug in all the LocoNet compatible accessories, be it Digitrax or circuits or some other vendors that support LocoNet, and have them functional with your NCE system.
Yeah, would you call that an emulator? I don't know if you would, but it's an adapter that lets you
Nah, let me think. I wouldn't exactly call that an emulator, because it
yeah,
realistically, with Digitrax, when I set everything up, you're using one command bus, or your control bus is LocoNet. So all my devices plug into LocoNet with the Digitrax system. With
throttles,
throttle,
everything.
yes. So with NCE, you would have your cab bus, which controls all your throttles, and it's your throttle network essentially. Its
Yep.
USB interface plugs into your computer. Then you have a second USB interface, which is the loco buffer, which then ties into a standalone LocoNet implementation where all your signal hardware will plug in. So JMRI becomes the go-between, and it can talk to both of them.
And
So,
the only caveat that I would mention about that is if you do, and I do like NCE personally, so I like them both. They both have
yeah,
advantages. And I would say at this point, it's kind of a matter of preference or whatever.
yeah,
The only caveat to NCE is that you're going to be pulling a throttle bus, a track bus, and a LocoNet bus.
yes.
I mean, it's an extra telephone wire. So.
Yeah, it's not that difficult, and LCC may make all of that go away anyway. So,
Yeah, and we've talked about that. We need to do a whole show on that at some point because and people are going to mention some of these other things, and maybe at the end of the show we'll have a moment to talk about some
yeah,
of the other choices. But you could spend whole shows on any of the other techniques, but Digitrax has a complete thing.
yeah.
You
So
know,
let's go over what's available for the Digitrax hardware side of the world here. So, the components of a basic signaling system are hardware for doing occupancy detection and signal driver circuits, or that's what actually controls what aspect your signal is displaying. So here, what Digitrax has is the BDL 168 LocoNet occupancy detector. It has
hey,
six. Yes,
one
sir.
second. Your video has switched over from the
Oh,
static intro
geez,
screen.
it jumped back on me. Wow.
No worries.
Okay. Yeah, I'm getting ahead of myself. There we go. Now let it transfer over. Johnny's always Johnny on the spot. I'll give him that. So, like I said, here we have the Digitrax BDL 168 LocoNet occupancy detector. So this allows you to plug diodes and give you up 16 blocks that you can detect your locomotive and or cars in. Now, the one thing is obviously it measures current draw on one of the rails. That's how it senses whether there's something there. So obviously your engine has power, it's drawing current, it can be detected. Lit cars can be detected. Any car with lighting in it can be detected. But non-powered cars, what you have to do is use resistor wheel sets or use metal wheels and solder your own resistor across the insulated side of the axle and wheel. And what it does is it lets it draw a minute amount of current so that the sensing diodes on the Digitrax system sees the current draw and knows there's something there. So that
That
way,
sounds like it'd be hard, but all you have to do is glue the resistor in there and use a conductive pin to make the contact. So
yes, yeah.
it's trivial. You can buy conductive wheel sets, but there's a cost, obviously.
Yeah, just like anything. And once you figured out how to do them, they're not hard. It's not like you have to solder a small resistor in there. And essentially, you're using a little surface mount resistor, and it bridges the insulated side of the axle. Now, here we have another style of block occupancy detector. This can be used with the Digitrax's SE8C signal controller, or with their DS64, so that it could operate turnouts based on block occupancy. And here we have the RD2 remote sensing diodes, which this is what the track power goes through for the BDL16 series detectors. So this is the little piece right here that you need to tell the system something's in the block that I'm wired to. And some of this other stuff we won't be talking about is the transponding. It's used for something totally different. It's like block occupancy detection, only it's two-way communication. You have to have either a transponder chip or a Digitrax decoder with transponding built in, so it could actually tell JMRI locomotive 1361 is in this block. But there are a lot of issues with it.
Yeah, if you're interested in what the capability is of transponding, I think there's other solutions like RFID and stuff
Yeah,
that you.
that I think what actually is more effective. There's known problems with Digitrax transponding.
Yep.
And now here, this setup here, the SDCK signal driver cable kit, is a series of connectors and the ribbon cable that's used to connect the signals to the signal control board, which is here, the SE8C signal decoder. This is the board that does all the signal magic. So essentially, this plugs into LocoNet just like the BDL16 does. So the BDL16 can say, hey, something has entered block 1, and then the signal is sent from there with your logic and your signal system to say, tell the SE8C to set the signal for that block to red, to say this is now an occupied block. So the two pieces work in conjunction with each other. So this can actually drive up to 32 signal heads with a lot of the popular LED type signals. It can also be used to control up to 8 slow motion turnout machines as either turnout control or control for semaphore signals if you happen to have semaphores on your layout. And it's a very easy plug and play system. Essentially, you have a connector that you put in the end of the ribbon cable that plugs in here, and then this supports, I forget how many heads on one strand of cable. I think it's 4. And then these connectors get put through the middle of the cable and crimped on. And then you can plug this right here, the signal mast base kit. And that essentially, you could put I think it's a 5/8 inch hole in your layout. And underneath of it, there's a mounting kit that comes with these. And then you plug the signal mast base kit right into the socket. Then you have 6 LEDs that stick above your layout. For N scale, they can actually use as a signal mast with 2 heads on it. So what some people do is they mount this under the layout and solder to the connections on here and tie a signal to it. So that's a possibility of it too. Or you can use a little header like this and solder wires that would connect into the socket as well for your own signals. And here's the mounting adapter. So this plate holds these connectors, and this little standoff here mounts at just the right height below your layout so that when you plug in the signal mast base kit, it stands just above your layout properly. Okay, and then this one here is your terminal strip mounting kit. You can use this in lieu of this connector. Well, I'm sorry, this mounting bracket and the signal mast base kit. What it does is the connectors that plug on the signal mast base kit plug into here, and it's got terminal strips so that you can run up to 4 signal heads be it, so that could be up to 4 signals if you're using 1 head per signal. Like obviously like if you're coming up to a siding, you would need 2 heads on a signal mast. Just remember the difference. The mast is the vertical pole. The heads are the individual signal elements on there that display an aspect. So if you're coming up to a siding, you usually have a dual head signal mast. The one head says the occupancy of the siding with a clearance into the siding. The other one controls the straight through route on the main line. So this here is great because you can tie any kind of signal you want into this board, and it plugs right into the driver cable kit. So it's fairly simple. It's kind of plug and play as far as putting this together. This comes with the connector and everything. You can solder all these wires out to connect to various things on your layout for the signals as well. So there's a lot of ways you can put this together, and then you connect it all via Locanet back into JMRI, and you program it from there with whatever signal system you would like to use. So it's a pretty comprehensive system. So I'm pretty popular, or not popular, but I think it's a pretty popular system in my opinion, and it certainly is a well-versed system. And like I said, it can be used with Digitrax or NCE or almost any DCC system. If it has a USB interface into JMRI, you can there again buy the local buffer USB from RR Circuits and plug that in and create a second connection in JMRI to talk to the signal system. So what I want to show next would be, let's see, where is it? This one here, Nemo Junction. This is a little case study on Digitrax's website on how they set up the signaling system and everything to use all the Digitrax hardware. So this had one power manager. It had a quad stationary decoder, which is a DS64 to run the turnouts, one SE8C for signal decoder, and had 2 of the BD4 occupancy detectors, which gives you 8 detection sections. So this is what the layout looks like in the actual track plan. And let's see down here. Here's the insulated joiner set up to form your basic blocks for detection. And then, so now what you have is the outer loop has 4 different sections that are numbered 1 through 4. Now these are connected to the 2 BD4s, which are used to detect the trains. And so these were the identification numbers of the different blocks. And the inner loop has been numbered 5 through 8 on the inside. So 1 BD4 controls the outer loop, 1 BD4 controls the inner loop. So here's your other insulated joiners. And here's what the bottom of the layout looked like. There's your 2 BD4s, your DS64 for your turnouts, and PM42 power management, which for a small layout like this, I don't know why you would have to have a power manager, but that's definitely something you could do.
Well, circuit breakers, that's you either need multiple small boosters that give you some built-in circuit protection, or circuit breakers, and it's more for protecting, from not welding a locomotive to the track or something.
Yeah, because they tend to be more responsive than the actual command stations are, and it's a lot cheaper to replace one of them than $180, say Zephyr, or heaven forbid something much more expensive like a DS240 or something like that.
Yep.
Okay. So here the BD4 can detect the presence of your locomotive or a lighted car on any of the 4 sections of track. It has been divided into 8 sections, and each of these is 4 in the outer, 4 in the inner. So the Nemo junction layout model uses 2 BD4s, but alternately you could use half of a BDL 168 because that can do 16 detection sections. So there's obviously economies of scale with using the BDL 168s, but just like with my club layout, when I was putting all the Tam Valley servo controls, some areas I could put a couple of the quad boards and I had enough turnouts to control them. But in the one passing siding in the middle of the layout, I only had 2 turnouts. So it now becomes, instead of $10 a turnout, it's $20 a turnout to use a quad board. So it's cheaper for me to buy 2 standalone switch right machines. So when you're planning out your scheme here, you have to consider, like here, I could use the 2 BD4s and it was probably cheaper to go that route, because considering both, you still need the SE8C to drive your signals.
And remember, you have a limitation on the length of some of the wires and cabling.
Yes.
Not to mention, you'll get into a mess if you're running your signals a great distance, and
Yep.
the power that feeds those LEDs is fairly low voltage, which means it's not going to travel very far. So you want to keep this electrical stuff. I know we all like to, a lot of us like to centralize our electronics a lot, but you do have to have this stuff somewhat adjacent to where your
Yes.
signals are going to be.
Yeah, that's exactly right, Andy. Now what you see here, this is the BD4 for your outer loop. So coming out of our booster, we have, this is the 44 pin connector, it looks like, on the SE8C. So from there, we're running our one common wire from the booster into pin 1 of the BD4. Now we have 4 other outputs go to each of your detection sections. So this one here would go to this block of track on the outer loop. Connection 2 would go to this end here, etc. So what it does is, you have the one rail is not gapped. You only put the gaps on just the one rail. If you gap 2, you use it for power management. You don't need to gap both rails for signal detection, though you can, but it only feeds current through one wire to detect. And here, this is the other one going to the inner loop for sections 5 through 8. And so here's what the wiring looks like under the layout here. Now that's just like when you wire a layout, you know, you have rail A or rail B. You should consistently pick the same rail for your detection, just so that when you go to troubleshoot things, you know that rail, no matter where you're at in your layout, is your detection section. It makes it a lot easier to, you know, like I said, to do troubleshooting and find out where you have problems at. So
It prevents you from tying 2 things together that you shouldn't and fried something. So,
yeah, I've had that happen with our club layout. Some guy touched one of the modules and he reversed the mainline bus. And every time I set that thing up, I pull hair out, which I have very little left as it is, trying to figure out where the bloody twist in the bus came from. Because it's okay if I start unplugging modules, it runs okay to the rail. But when I plug in the module that has the twisted section, now I've created a phase short across the rails.
Yep, and on modules that can be quite simple, but on most of our permanent layouts, that's a real problem. So
Yeah.
consistency and good documentation is key.
Yep. So here they're using the PM42 Power Manager to separate the inner and outer loops, so they can operate independent of each other without, I give you short the outer loop, you know, it won't cause problems on the inner loop with your switching area. Okay, let's see. So here's what the signaling looks like at the interlocking, which we have the crossover here in the middle and the siding out to where they're servicing the business, and then we have this junction line here. So this is detect, you know, where your signals are to show you whether it's safe to cross, etc. And here's what they would look like there. So you can see the switch signal, or the signal going to here, is just a signal, dwarf signal, to say whether it's safe to enter this section of track. And you have over-under signals here determining whether it's safe to take the crossover or not, plus the status of the main line at all these points. And here you have single signals controlling your junction line crossing over the other main line.
Are these wiring? Are you wiring turnouts with this design? Are they wiring turnout position in so that it will also set a signal against a person if the turnouts are signaled
It
against?
looks like it because of the design here with the dual heads. It indicates position. I believe it's the turnout indication as well.
Yeah, but you'd have to tie that back to the logic control board. So.
Yes, yeah. So that would have to be controlled so that when you would have to have logic so that when you throw the turnout, it would also send a signal to throw the appropriate signal as well.
And that's the point of having feedback. A lot of people have asked about that in some of the hangouts we've talked about having feedback on some of the circuits, like the NCE systems. You've got to add that feedback board to it to get that.
Yeah.
And
See, there, LocoNet, you can have feedback through LocoNet.
yep. And while I love servos, and I do, that's what I'm using, and it's your fault, Barry. But tortoises do have that feedback built in, so you don't
yes.
have to do that.
And to a tortoise, you can use the contacts to supply feedback to an NCE system via the what's the AUI board, right?
Yep.
So here I got a question from CNL line. So if you're using 22 or 24 gauge wire, how far can you go before you start to lose power? Well, we're not drawing a lot of current, so even a 24 gauge wire, you could go. What would you think, Andy, with the amount of current we're drawing through here?
Well,
hundreds of milliamps, so probably,
I would say it depends. Okay, so first, there's multiple parts of this, multiple components of. So the occupancy detection is pretty sensitive. So you put that on your feeders, on your feeder going up to the rail, or sub buses. Those are really sensitive, so you want to get it as close to the track as possible. So keep it no distance at all. The logic feedback for the logic could go a really long distance, because that signal is just kind of a digital, it's on or it's off kind of status.
Exactly.
So that's irrelevant. The limitation with distance going out to, say, signal heads, for example, is going to be a limitation of the voltage drop to the LEDs. So it's going to depend on your signal that you buy, and how much power you put through to head your signals. These NJ Internationals that I've got, and I hope to buy LEDs that are very similar to these because they're very tolerant.
Yeah.
I plugged them directly into an Arduino, and they tripped without any difficulty. So I would say you can get quite a bit of distance out of those LEDs, 15, 20 feet. The limitation is going to be occupancy detection, though.
Yeah, because with both the remote sensing diodes for this and other systems use the coil transformers, they have to be on a feeder or sub bus for the section you're trying to detect. So that's why I said normally if you're not using power management, or if this is within a power management section, you only need to gap one rail. And the feeder to each of those rails the reason you don't want to do the sub bus, Andy, that's what I just thought. Shouldn't even have said sub bus. It has to be on the feeder to each individual physical block of your layout, what you want to detect. So that's why when you gap the one rail, you put the transformer or the sense diode on the feeder to that piece of track. That way.
Yeah, that's why the sub bus works better for that application.
Well, the thing is, the sub bus, you can detect somebody in the adjacent block.
Yep.
But if you put it on the feeder, you won't.
Oh. Well, okay. So I guess a lot of this. Okay, so the signal masts and the logic and the turnout feedback, etc., those are really straightforward, and pretty much most of our layouts are going to be really similar, with the exception of servos and stuff. The occupancy detection is going to very much depend on how you wired your layout.
Yes.
Since Chris asked, Curtis asked about this. He's going to sub bus sections of his layout, have a master bus, have a sub bus,
Yeah.
and have particular feeders. As do I.
Yes.
If I put it on my feeder, because I have a feeder for every section of rail,
Right.
and I need occupancy detection detect an entire strip of say four or eight sections of rail, I have to put it on my sub bus that goes to that block.
Well, yeah.
Otherwise,
Yeah.
I have to use. Now, there's another choice is that you could use multiple occupancy detectors, one on each of the feeders, and
Yeah.
use logic inside of JMRI to tie all of those occupancy detectors with logic, JMRI logic, back to one action. So
One
when
occupancy
they
section.
alter.
Yeah. The
But
biggest
that's
thing
a
is,
little more complicated. So the sub buses work better.
yeah, it all comes down to what are your occupancy sections,
And
and
how many feeders are you running?
yeah.
You know, if you got a feeder on every section of rail, that's gonna it's gonna either require a whole lot of occupancy detectors or whatever. There's some complexity with that.
Yeah. But the
So
biggest thing is, like, if you're gapping your rail, that would assume all the gaps in between are soldered. So as long as you have one transformer on that contiguous piece of rail that is your occupancy detection section, then that would detect anything that's in there. But
yep.
if you have gaps in the rails within one occupancy detection section, then you have to have multiple detectors, one on each feeder to each unique piece of rail. Because obviously we know we have to gap our rails for physical expansion and contraction due to environmental conditions. So if you have a particularly long block, you might actually put gaps in the middle of a occupancy detection section.
And those may just be expansion and not have an electrical
Right.
benefit.
So yeah, but see, the thing is, in order to be able to detect a train anywhere within those gapped pieces of track, you'd have to have one detector for each contiguous piece of rail within that occupancy detection section.
So I would say to summarize this is the simple way to think of this. The occupancy detector needs to go on the only path of signal between your DCC system and a particular section of track.
Yes.
If you have only one feeder, then you can put it in the feeder. But if
Right.
you have numerous feeders, you've got to isolate a section of a bus that feeds just those feeders and put it there.
Yes. Yeah, Jim Lofton just mentioned he has multiple feeders within one detection block,
I
which
do too.
you're right, you can do. If you have a long enough detection block, you will have multiple feeders. Now,
So
if
you
it's
either have to do it with electrically by isolating multiple feeders onto a strand of wire and then pulling that wire through your occupancy detector,
right,
or you have to have multiple occupancy detectors and
right,
use logic and JMRI to bind
yeah.
them.
And see there, if you take your multiple feeders and put them into a small sub bus, then you can put one detector on that sub bus.
Yep.
Now, CNL said here, so well, we really did mean it's not good to use 22 to 24. It's it's the distance is dependent upon the amount of load you're putting on it. The more current you draw, um, you're going to have some voltage drop over a longer distance. So you can probably go 15, 20 feet with not a lot of current draw because the line can only handle so much current and or voltage.
But the occupancy detectors are tunable, but the problem is
Yeah.
that line distance may just the distance and impedance in that line or the voltage drop per se
Yeah.
may also give you may trip those occupancy detectors.
Yeah.
So I think it's better as close as you can get it to the locomotive or car, as close as you can get it to the rail, the
Yeah.
safer you are.
And then you can run the wires from your detector back to your detection board.
And that
And
can go a great
that can
distance.
go much because that's very low level voltage. There's no current draw because essentially with both the remote sense diode and the current transformers, the fact that you draw current through them induces a voltage in that circuit, and then that can be fed back. They can travel pretty fair distance, so like you could have a more centralized location. But anything, I would, you know, limit it to, like Andy said, maybe 15, 20 feet top. So A lot of us, we could do, if it's a high density area, kind of put all your gear in that one area and then have more equipment in another area. Because you can run the 22 to 24 gauge feeders that would tie your sense diode or your current transformer back to your detection board.
Oh yeah, the limitation is more that you're going to end up with so many doggone wires that you're better off. I know a lot of people like to centralize.
Yeah.
Uh, you're better off to distribute or to put the boards closer for a whole host of reasons,
Yeah.
but not. But one of those reasons is likely not losing power.
Yeah. Now here, this is showing you what the connectors look like in the Digitrax system. They use what's called an insulation displacement connector. So this 10-pin ribbon cable allows you to have up to, I believe, 4 heads on it. So you put this cable into this little carrier here and then take the black body and push it down, and these little wedges here pierce the cable and contact the wire inside. It's a very common electronics connector.
Yeah.
And then here's what the different pinout looks like on it. So, and it's fairly simple to do. I mean, so here, this was using the DS64 to control the turnouts in here, which you don't have to do if you have something else that you prefer. Like I said, I use Tam Valley products, and they make a board that is LocoNet compatible that you can drive servos with, because the DS64, that doesn't do servos, right, Andy? It just does twin coil and stall machines. I don't think it does a servo.
No, and no, I don't think no, because it doesn't have the control for stop points and such.
Yeah,
So
it doesn't have the pulse width modulation. So
right, so you'd have to have a servo controller, separate board. You could use it to trip them, to trigger the fire, but it's just more complicated than necessary than to buy something well tailored for servo.
And so this picture right here is showing you one of the connections coming off of the SE8C through the ribbon cable to a signal mast. And then essentially this is now a 3-aspect dual head signal. And it's just ran right off of this single cable. So altogether you have 8 connections here that can drive up to 16 heads.
And that'll seem like a whole lot to you, but I'll tell you, if you've got a junction, like I've got a few turnouts together, it's going to eat that whole board just for those few.
Oh yeah, well you saw in the in the track diagram here. Back here.
Yeah, it's every set of lights. Everywhere you have a green red or a yellow red together, every one of those little combination of lights eats one of those.
So right here, this is 2 connectors off the SE8C. This is another pair, so that's half of it. And these 3 here take up 3 more, even though they're not using dual heads. But you could run the cable out and hook up another 5 heads to that. Just remember, each of those cables does dual head on a single mast or on dual mast, because you can run the cable between 2 separate signals on a main line that only have, like you're running signals along a long distance of track. You'd run that 10-pin cable down between the first signal mast and the second signal mast and control the 2 heads independent. That would take up only one of the 8 connectors on the SE8C.
Yeah, you could easily eat one board up just with one signal bridge or a cantilever tower. But these aren't very expensive. These aren't very expensive boards, so.
Yeah, I forget how much they were, but well, let's take a quick peek.
Jim Laughlin said no, up to 4 signal masts per connection. So maybe you can do 2. I guess you can do 2 aspects per plug. So
yeah, because each one, the 10 pins supports one of the signal mast kits, which has 2 heads per connection. So you could technically control 16 independent heads.
Oh yeah, yep.
Oh no, 32. I'm sorry, you're right, Jim. I was thinking there was 4 before while I was
I
looking
know
this up.
that count was messing me up a little bit too with
Yeah, so
that.
okay. So it's four independent masts per connection, which is 4 single head masts, which makes 32 on the eight connectors on the board. Right. So
And if
yeah.
you wanted to do individuals and split them out, you'd have to split that plug out, I guess. So
Well, no, because this is if you plug into it, there's a definite pinout assignment for each of the 4 heads on here. So if you plug it into the mast kit, it's already got the pinout configured. If you use the terminal kit, it's already got the connectors marked to drive the 4 independent heads.
yeah,
So
yeah.
each one is like a common, and then 3 wires or however many wires for each head. Okay, let's see here.
They've really done a great job of documenting this. So the
Yeah,
case studies are exceptional.
yeah. So this here is your signal mast head that you can buy from them. Like I said, you could paint this and just plug it into an N scale out, and it's sufficient for a signal. Now, obviously, if you want a prototype signal, you won't use this. You'll use the terminal strip board and plug this connector into that, and it has terminal strips to wire in whatever physical LED signal that you want.
Tell you what, it's a great way to get started though. Is buy some of those, wire them in, and then go back and replace them with
Sure, yeah. And here's
or
the terminal strip mounting kit. So the cable plugs into this socket here, 10-pin socket. Then you have 10 screw terminals that tie your signals into it. So it's essentially the same thing as that, but you can plug your own signal in.
yep, and just screw it straight down to the
Yeah,
resistors that are already pre-soldered to the
and
MJC.
this is using a standard, I think, 10th inch header. So the pins are 0.1 inch apart. So in theory, you could take your um, signal and wire it to a header plug and stick it right into this connector and not even have to buy that board if you're not using the Digitrack signal masts.
Well, that's really nice for replacing them if anything happens to them or if somebody
Yep.
bumps one and breaks it off. That's a really and those you can buy 100 of those for $4 or something. So
Yeah, yeah, exactly. Yeah. So this is a very versatile system that can cover almost anything you want to do. So I'm pretty fond of the Digitrack setup. But obviously, we all want to investigate the different technologies. I mean, this works great in a Digitrax environment, but it would work just as well in almost anybody else's environment. So next thing we want to talk about is our circuits. They're one of the other bigger companies in our hobby for electronics, and they are one of the first ones out there to actually have layout command control components here. So we'll do a quick little foray here. This one here is the LCC PowerPoint. This is what it has: 2 LCC jacks and a power supply, and this powers your nodes on your LCC network. Now, this LCC repeater just is a second signal amplifier that boosts your signal over long runs. And the terminator here you need at the end of an LCC bus. So the last connection, like right here, you see the last connection on an LCC bus, you would plug one of those terminators into one of the repeater or the power node. And this here is this is your USB interface into the LCC communications bus. And then the last thing they sell right now, this is called a tower LCC. So it has an in and an out connector. And essentially what this does, it has 2, I believe they're 10, are they 10? Yeah, 10 pin connectors here that plug into all the other RR circuits modules, like for their signaling and everything. So that ties them into the LCC bus and allows you to communicate with them through JMRI, but using an LCC network here for everything to talk back and forth. Now, as we've already mentioned, loco buffer USB. It's from RR circuits. This is what you would need for any non-Digitrax DCC system to tie a LocoNet based signaling or other LocoNet based accessory into JMRI so that you could access it through, say, NCE or something else. Now, what I've looked at so far, and I did some research on it, the tower controller, you see the TC Mark II there. That there is a 64-line input-output controller. So it can receive inputs from block detection. It can send output to signal controllers. So it's pretty versatile, and it has a lot of lines. Now, what they have for it is what they call the BOD8 block detector. And then that's what allows this to sense where locomotives and cars are on your layout. And then, let's see. So yeah, here's your block detector modules. This one here uses these current transformer coils. So these connect onto the board here. And this is where you feed your feeder wires or your subbus wires through. And then these are wired back to this board. And then this here, much like the Digitrax system, uses a ribbon cable that would plug back into the TC Mark II and then transmit all the occupancy information back to that. And this here.
While you're looking at these boards, I got a question that nobody else has asked yet. Have you seen, since you talk to a lot more people than I do with real world experience, do you see a favoritism or preference or benefit of coil based versus diode based detectors? Is one of those a better choice? Is one of them more controllable?
A lot of the detection systems out there are coil based.
Yeah, it's been around a long time.
Yeah, Digitrax is one of the few ones that I know of that use sense diodes.
Yep.
So, because current transformers like this are a lot more sensitive, and they're a lot more adjustable than the sense diodes are.
I know a lot of people were saying you had to wrap the wire around them a few times, kind of make a coil to get them to be sensitive enough. But that gives you some flexibility.
And
but now I'm starting to hear about these diodes, and that seems, it's solid state. It's more predictable.
Yeah, that's the thing. The problem is the circuits that these tie to aren't designed to use the diodes.
Okay.
They're designed to detect, because what it is when you run the wire, through here, even if you go straight through, or like Andy said, you do a few loops through there, what that's doing as the voltage passes through the wire, it's inducing magnetically a voltage in this transformer, because it's obviously it's a magnetic coil. So if you put a wire through it or another loop through it, it introduces a magnetic field, which creates a difference in potential between the two pins in here, and it creates voltage. And then that is what the detector board sense. I'm not sure how the remote sense diodes work. I don't know if what it is because obviously a diode has a certain point, voltage starts conducting through them, so it may be that causes it to trigger. If I see an output on this side of the diode, I know there's something there.
But I got a pretty good idea how all it's looking for is a difference of voltage. So if you're putting, say, 14 or 15 volts, like on an HODCC system, through, and there's a little bit of resistance on there, that's going to drop by just a touch.
Yeah.
But actually, I'd say the coils are probably better at detecting amperage drops, because that's what you really care about. It's not voltage drops, it's amperage drops.
Yep.
Because, and you can build either one of these. If you're kind of savvy and can read a diagram online, you could get diagrams on the internet for how to build these little detectors, like dirt cheap. And I've been looking at the coil and the diode detectors, because you could build either one, and I just hadn't heard any good real world experience as to the benefit or plus of one over another.
Yeah, I see right here, these coils here, they say they connect to the BOD8 using twisted pair cables, such as Category 3 or Category 5 network cable. So you can run one cable run that can fan out and feed 4 of these detectors. So
And
it's
they can go a heck of a distance because
oh
all it
yeah,
is it's just it's just an on-off digital signal. It's not. It doesn't care about whether there's a voltage drop of anything
right.
reasonable.
Now see, like C&L mentioned earlier about running a long distance, a category 3 or category 5 has like a 300-foot length limitation, and they run about 26 to 28 gauge. They're even smaller than the 22 to 24 gauge wire. So you can definitely run those kind of wires for these purposes, a fairly long distance.
Oh yes.
Now the other thing that plugs into, into the TC Mark II here, let's see, is your 4ASD-4, which is it's a 4-aspect signal driver board. So it can drive 3 to 4 aspect signal lights using 3 LEDs in series for each position by providing 9 volts, the dropping resistors, and you can actually have a 4th aspect for the signal head coming off of these boards as well. And this just uses a simple ribbon cable that plugs back into the TC Mark II. And so that one board can control a series of detectors and signals for a particular location. So it's actually a pretty versatile environment too, much like the Digitrax. Now, the nice thing with it is the TC Mark II has built-in LocoNet connectivity. You can do very similar things with these boards by using the Signal Man. And there's 3 different configurations as far as what kind of connectors it has. But the Signal Man, it doesn't use LocoNet. It uses what's called the LocoNet compatible simple serial bus. So it's basically a 3-wire serial connection. You can tie it into LocoNet by using one of their gateways. It's a little module that has the simple serial bus terminal strips on the output, which is 3 wires, and the other side has a LocoNet jack that allows you to plug it in, and then it can send signals back and forth over the SSB to LocoNet. So I really didn't look too much into what the Tower Man. I think this here, it's a 16-line controller. Yeah, see this drives other modules in the system, and the Watchman is also uses block detectors and IO lines. So they have a few different systems you can use. Like these are really designed for DC systems, not for DCC. That's where stuff like the Tower, the TC controller Mark II comes in. Now here's your simple serial bus adapter that has 2 LocoNet jacks and 1 simple serial bus connector, and there's a power jack because simple serial bus needs power supplied to it.
That's what I was getting ready to ask you is how does that tie back to JMRI? Because it doesn't
Well,
look like any.
this is the piece you need here to tie it to JMRI via LocoNet because
Oh, so you got to have that and
right.
a lot.
Yeah. Now see here, this is the newer version of it. This has 4 LocoNet jacks, 2 simple serial bus plugs, plus a built-in power supply. And then that way you can use this to split out different networks. Like you can run your simple serial bus to 2 different directions and have this in the middle, so that way you don't have any length limitations. And that's something when you're designing the wiring plans for all this stuff, put your stuff in centralized locations where you can to minimize your wiring runs. Like in my club layout, we have a 117-foot layout, and we run it with the Digitrax Zephyr Extra, but we put it in the middle of the layout. So rather than have to change all the wiring underneath the heavier wiring, I put it in the middle. So now instead of going 117 feet, I'm only going about 60 feet each direction. Now I can use smaller size wire for my power buses. Same with this stuff. Centralize where you can. So your feeders out going out to detection, like transformers stuff. are kept in a centralized location and fed back to one board. Then you only run one LocoNet line to the next set of boards. And that way, because some layouts that are small enough, you can put all the stuff in one big cabinet and run feeders out to everything, but it creates a spaghetti nightmare. So you keep all that tied into one small area and run the LocoNet or what simple serial bus or whatever it takes between the modules.
Yeah, I'm using a kind of distributed fashion with
Yeah,
mine. So I'm going out to, I bring a power bus around the layout, and then there's no big bunch of stuff at any one point
yeah,
other than the DCC base station. But that's a kind of political decision. There's
sure.
two philosophies, and we can argue. There's benefits to both.
Yep. Here's something that's nice about the RR circuits designs. Just again, like Digitrax, they use a 10 conductor ribbon cable with the same kind of connector. But every board they make is designed to snap into these plastic mounting tracks. They
Oh,
have
cool.
cutouts for the connectors that tie into the ribbon cable, and you just screw this plate under your layout and snap the boards in and run your connector, your wire, your ribbon cable between them. So it makes it really nice for mounting the boards under there. It makes it much more professional looking. And then they have their range of power supplies for the different, circuits they sell and everything. So I consider Digitrax and these two kind of on par with each other. Obviously, there's other, um, designs out there, but let's see if I can pull up this one here. I
Well,
have,
they're compatible and speak the same
yeah,
language
yeah,
and
that's what it really is.
interoperable.
Let me see if I can go over here to this. I'm going to do this. So this is a DCC decoder for controlling LED color signals, and this works UK standards you can buy or program for North American standards. It's a fairly simple board. It connects into your DCC network, and then you use an MRA standard accessory, the extended accessory decoder commands to control it. And then this can drive Pensy, position lights, 3 color lights, whatever you want, and you can get it for common cathode or common anode LED wiring. So it's definitely a nice individual little design, and you just strictly control this via DCC commands. So you don't have to, you probably have to do programming to use it in JMRI, but it's definitely an alternative possibility for use. So
Yeah, I really like that.
yeah, it's an interesting little design. So I think it's something for me to do a little more research on because I I have my little demonstration layout I use for train control system stuff. I'm going to repurpose that and build it into my DCC demonstration layout. So I'm planning to put a small signal system on there. Kind of hoping to wait for the LCC stuff to mature a little bit more. But
Sure.
I know there's some manufacturers that have product coming in the pipeline that have more capabilities. Right now, the only one I know of completely that has a system is the ones from RR Circuits.
Yeah,
But
and they had that at the NMRA, and they'll have it at any. If any of you
yeah,
guys go out
it
to
was
bids,
at Amherst last year. They have a little demonstration layout showing turnouts working, signals working, and it's pretty easy to set up. And what they've done is the tower LCC essentially is the interface, like I said earlier, to the LCC bus. But then the other side of it has the standard accessory control bus that all the RR circuits boards plug into. They're
yeah, so you
at
just
the
daisy chain them off that one board.
right, so you use those nodes where needed to plug in other modules, and you can put those nodes wherever you need to. On a larger layout, you might have just a single LCC bus running around your layout. You just pop them in where you need it. The nice thing with the LCC bus is it uses standard computer network wiring, Ethernet, Category 5 wiring. So you can buy pre-made cables from any cheap computer supply that'll plug it all together. You don't have to buy special LocoNet cables or anything like that. So LCC is going to be an interesting route.
And
And
there's no reasonable distance limitation. Not
no,
reasonable.
because a single Ethernet cable between repeater points can go 300 feet.
At
So
least.
yeah, no, that's the official um, EIA wiring standard on Ethernet
Yeah.
cable. It's 100 meters is what it is, 100 meters,
Yep.
which is roughly 300 feet. Now, I know Dick Bronson is eventually working on taking his different modules he has now, like the TC Mark II and stuff, and making LCC versions of them. So right now you have to buy the LCC, the tower LCC, and then plug a TC Mark II into that to be able to control it via LCC. The goal eventually is to add the LCC interface to the different modules so they all talk over the same bus, and it essentially would do away with his ribbon cable bus and put everything to have an LCC connection on it. Which is then it becomes I want a signal here, I buy a module for my signals here, plug it in, and then wire my signals to it and do the programming in software. You know,
Oh yeah, and you're future proof and the program is easier. I would say the only thing missing from LCC is the thing I think is so awesome about the Digitrax is that the documentation, the amount of people using it that have wrote it up on forums and on their websites is just not there yet.
yeah,
You're relatively savvy. LCC is out in the wild. You can buy it and use it today, but you need to be a little bit savvy to kind of get through the pains and pitfalls of it not being well documented yet.
yeah. And right now, like I said, the only company I know where you can buy components that will work are our circuits. Everything else, like Andy said, is a kind of a brew your own. You mean you can, if you're into the Arduino thing, you can buy a DCC shield, or you
Yep.
can buy components where you can load LCC software onto an Arduino and turn it into control nodes. But there, it's a roll your own system.
It
So
is definitely not. It is not that hard, but it's not plug and play. You could write that off.
yeah, it's not for the faint of heart at this
Nope.
point. Even for guys like us, we have to invest time and effort into the research of how to do it.
Yep.
You know, and I do this stuff for a living, just like Andy does with computers. Sometimes I just want to plug it in and have it work. You know, even though sometimes the fun is figuring it out as well. So
And a year ago, you couldn't even say that about LCC. So it's really came a long way in a year. If you're relatively tech savvy, you can make LCC work today. If you're not very tech savvy, the Digitrax system is still probably the best bet for at least the next couple years.
yeah, I kind of would agree with you there, Andy, because they have probably the most fleshed out system at this point. So I'm pretty happy with what they're offering. And more than likely, when I build my layout, if LCC is not up to standards yet, I'll
Yep.
probably go that route. But by the time I get to it, it probably will be because it's going to be a while. But
Well,
my
I've been
demo
basically
layout,
holding
I'll
off.
probably do it with Digitrax.
Well, I've basically been holding off. I've got my layout up, and I've got a loop of track running recently.
Yeah.
I've got some signals. I've been actually building the masts and playing with some basic wiring for. A year ago, I decided I wouldn't make a decision. I would wait on LCC, but I have to say at this point, we're still kind of waiting on LCC.
Yeah, because like I said, the hardware is not there yet. But next year, I think you'll see it change. Because I mean, I know there's some stuff in the pipeline from some companies, and then Dick Bronson's obviously looking at taking, like I said, the LCC connection and adding it into his existing modules, which is a redesign of the board. But essentially, he's doing away with his 10-pin communication bus and replacing it with LCC, which, in the end, that makes more sense because then everything talks the same language. If I like his signal controller and Joe Blow's turnout controller, I can do that with LCC.
That's
Right?
the beauty of it.
Yeah,
Yeah.
right now I can do it with LocoNet compatible stuff, but there I'm tied in to you know a proprietary bus versus an open standard bus. And LCC has a lot of possibilities going down the road where there's going to be boxes you plug into LCC. It has an output to your DCC system, whichever one that may be, but you have universal throttle connections. So if I want to plug in an NCE throttle, but I have a Digitrax command station, it will work.
Yep.
So that's the some of the end goals for LCC is to make this as universal as possible, so I can buy the best of the pieces that I want to do what I want to do. You know, so
And Digitrax just wasn't designed to be the local net wasn't designed to be universal. A lot
no.
of people have built modules for it, like our circuits, and I haven't heard any complaints about their modules being
No.
compatible. But there's a lot of people who make local net compatible products, and if you went and bought 10 different products from 10 different vendors and plugged them into local net, your mileage may vary.
Good point. Well, I kind of think we covered what I've wanted to cover tonight. We definitely we'll be touching on. I think next month we're going to try and talk more about the hardware, as far as what kind of programming you would need inside of Digitrax, or I mean JMR. I mean, to make this kind of hardware work. It depends. I don't know if I'll be able to get the hardware pieces together to actually do some programming examples. So if we can find, I think Chris has already done some of this, so we might, tap him on the shoulder and have him show some stuff.
Are we doing? Are we doing next month?
No, that's in December.
Oh, December. That's right.
Yeah, so
Okay.
next month we're continuing the signaling discussion, but we're trying to say now we've introduced some of the hardware needed. Now let's talk the software side of how do you make that hardware go and do
And
what it's supposed to do.
addressing.
Yeah. So
Yeah.
that's something we'll have to put some work in over the next month to get that ready. And then Andy and I are going to work on getting Arduino stuff ready for the end of the year for the December show. So stay tuned, folks. We shall, see you again in another month. Thank you for all watching and putting some of your questions into the chat. So we're still working out some of the kinks in this new system, and hopefully they'll add some more features to it over time. But we shall see how that all works out, people. All right, so just to remind everybody again, you've been watching a YouTube Model Builders Hangout tonight. We have YouTube Model Builders as your free resource for model railroading information on the internet. We have our free online e-magazine, which just came out last month again. And we have our live chat and presentations on Tuesdays and Thursdays, and the once a month YouTube Model Builders live show. So for all the information about what's coming up, what's on our schedule, go to www.youtubemodelbuilders.com and check out everything we have to offer there. And don't forget to go to the eMag menu on the right and go down where it says to subscribe, and then you can get emails whenever the eMag is published, so you can download it. And also we will be using that email system to send out notices for special events, etc., like we had with Kathy Milliot and everything. So hopefully we will be doing more of them next year. So folks, thank you very much. Appreciate you hanging out with us this evening, and we will see you once again next month. Take care, folks, and good night, Dwayne.